Well, thank you very much to the hosts of this very interesting conference for having us here in beautiful Bern. As already mentioned, my co-author Nico Ster cannot be here. He had to undergo surgery recently and he's not fit for travel. We wrote this paper together, so it should not be a problem that only one of the authors is going to present it. My name is Adolf. I'm originally from Vienna. I've been living and working in Germany for the past years at Zeppelin Universität on the German shore of Lake Constance. I'm originally a media scholar. Before I launch into my presentation, I want to take the opportunity, since we're in Switzerland here, to remember briefly the recent passing of one of German language, probably most finest sociologist, who just died a very untimely death. I'm speaking of Professor Kurt Imhoff, and I want to dedicate this paper to him. My presentation is not going to show you a lot of content, so you can focus on actually listening to me. I'm going to give a paper in the classical sense by reading it. In the early 19th century, Adolf, the Belgian pioneer of empirical social research, investigated what he called the homme moyen. This average man, or so Quetelet presumed, is the gravitational center of society. Measuring individual and collective social and physical attributes allowed one to trace the dynamics of society. Quetelet was the first social researcher to accumulate and analyze large stocks of empirical data. He may therefore be described as the originator but largely forgotten predecessor of today's data scientists. Our presentation today edges out similarities between the pioneer of what he himself called social physics, much to the dislike of his contemporary Auguste Comte, and today's reincarnation of very similar ideas. We will try to demonstrate the likeness of these approaches to the social world and uncover some of the fundamental and, in our opinion, flawed premises of both endeavors. Let us start with looking briefly at Quetelet's work. Quetelet's social physics may be depicted as the empirical description of the successive restriction of the deviation from the mean of relevant individual properties of individuals and of society in general. Examples are the extent of societal conflicts, the distribution of wealth and income, or crime statistics. For example, he used the measurement of the physique of 5,738 Scottish soldiers, from which he calculated the average man. Not only did he calculate the average man, he also gives us an idea about the distribution of insane people, and this is what's particularly disturbing to maybe our host country, but also my home country of Austria. It's generally observed that in the mountains there are more idiots than in the plains. What do we make of that? In 1831, he described his method and scientific aims as follows. Initially, by examining the physical and mental abilities of the people, I wanted to discover the law by which they develop at different ages, and learn about the modifications that impact upon them according to place, time, season, sex, and all causes in general. However, in order to estimate these properties correctly and determine their relative value among different peoples and in different periods, one would have to be able to measure them, or at least show that this would be possible once science had collected sufficient observational data. I now hope, he goes on, to have clarified this possibility to the fullest so that no further doubt can exist in this regard, end quote. In the final analysis, social physics, as Quetelet envisioned it, was to be more than mainly a descriptive scientific activity. It was designed to capture the nature of social reality. Social physics, if properly conducted, that is, through a complete enumeration of social facts, would divulge the causes of social activities. Quetelet viewed the empirical data he collected and the regularities he inferred with respect to the distribution of certain properties within a population as the key to the solution of a whole range of political and social problems. He proposed the best age for drafting young men into the army, ways of suppressing crime and deviant behavior, or the modification of the variability of the price of crops, which he found to be the largest influence on the mortality and reproduction rate of people. It was not only possible, he was convinced, to discover social regularities presented by observable social facts, but to uncover social mechanics of social life, and hence to intervene in their workings. While the demise of social physics in its battle with its sibling discipline sociology had obliterated the term from mainstream social science for almost a century, recently it has reappeared with renewed confidence. What's more, present-day proponents of big data-based social physics, such as MIT's Alex Pentland, do not seem to remember their once eminent precursor. They are, thus, susceptible to repeat his methodological and theoretical errors. What they share with Quetelet is their understanding of social physics as a science that does not merely want to describe, rather than change society. Driven by advances in big data, social physics returns both as an idea and a research program. What seems to have resuscitated social physics is an unprecedented availability of digital data on ever wider areas of social and natural life. As we move more and more of our everyday activities into the web or use ICTs to assist with our daily chores as well as our professional work, ever more activities produce a data trail. This phenomenon, presently discussed under the title of big data, is a token for the increasing informationalization of contemporary society. And as Jim Cortada pointed out yesterday, if you want to understand modern society, you cannot do that without understanding media and ICTs. The process might be called datafication of everyday activity. This development is nearly inescapable, since taking part in social exchanges today will involuntarily produce such a data and person-based information trail, even if we don't know about it. And even if we know about it, for example, being recorded and uploaded on YouTube. This kind of person-based big data has at least three sources. First, the new communicative possibilities of the internet, especially of what is commonly referred to as the social web, go hand in hand with new forms of self-presentation and self-revelation. Second, on a more fundamental level, another source of big data is inscribed in the material properties of information and communication technology, which is digital and computational technology. Data are never really transferred across networks. They are copied. Computers are copying devices. And copies may be kept, connections logged, localities noted down, contact frequencies registered. The enormous extension of sensor networks, so important and instrumental for the convenience of digital technology, are natural environments of record. A third source is the illegal retrieval of servers full of personal information by hackers, security agencies, or foreign governments, as we have known at least since Edward Snowden's disclosures. This development seems hardly reversible. Not only do we as a society profit from these technological and environmental realities, but we live deeply entrenched in them. One of the major problems of big data is the factual asymmetry with regards to knowledge of and access to data. Not only are we only dimly aware of the ongoing changes in the information economy, we are also not fully conscious of what these changes entail. We have limited say in the collection and the sale of such information, and we may not store and compute it the same way larger corporations and institutions can. They have a significant head start. To a social physicist, the age of ubiquitous computing must seem like the land of milk and honey. While Quetelet and his colleagues had to collect their data in a laborious process, today's data troves lay by the roadside. In just a few short years, We are likely to have incredibly rich data available about the behavior of virtually all of humanity on a continuous basis, says Alex Pentland, and echoes the vision of his 19th century predecessor. Newly discovered social physics claim is just as universal as the data it is based on. As Pentland in the spirit of Quetelet states, social physics aims to move beyond merely describing social phenomena to building a causal theory of social structure and a mathematical explanation of why society reacts as it does, in order to eventually build or even engineer what are to be better social systems, and to ultimately, and I quote again, plan the future. We do not concur with the assumption inherent in much of big data-based social physics discourse about the practicality of such observational data. And let me tell you why. The power of information has been overestimated in the past, and this is likely to happen again. Like Quetelet, Pentland's desire to comprehensively depict social reality leads to a fundamental fallacy. Since causality and its subsequent deployment for social steering are predicated on a complete depiction of complex social phenomena, failure of such a program is inevitable in our opinion. Quetelet was of the opinion that determining causality as the precondition for controllability of social phenomena was only possible, as I said, when the phenomenon in question could be exhaustively observed and measured. His problem was one of resources, not of methodology. Pentland seems to share this view, only he has different means available. The bigger the data set, measured ideally every millisecond, the more effective the resulting knowledge. Or so it is believed. This is not only the point where Quetelet and Pentland's assumptions are in full agreement, it's also the point where they're both mistaken. Let's take, for example, the much discussed tool of predictive policing. Using data pertaining to the type, location, and time of criminal activities, and these are usually the three parameters, some police departments use predictive policing to prevent crime before it happens. But the algorithms employed reveal nothing about the reasons of why such crime happens where they do, or what measures should be taken to prevent them. That's not an inherent feature of the data. Such data are also merely probabilistic, and the information that derives from them is nowhere near what we would call knowledge. Thus, both the dangers as well as the promises of contemporary social physics based on big data might be exaggerated. Even if it were possible to measure all social interaction and to derive observational information by aimlessly correlating all available variables, the lack of theoretical insight would lead down dead-end streets. The practical power of knowledge, as we try to show in the book that you mentioned, does not reside in accounting for every last one of a phenomenon's attributes. Rather, the practical power of knowledge is a function of controlling the social context of its realization. The question then is not so much whether big data and the social physics based thereupon fail to produce the kind of practical knowledge they aim to create, but whether the overall social policy climate may be seduced to create the conditions under which social physics may become a viable ideology for a future society. It becomes clear that the forefathers of social physics weren't only driven by a methodological interest of ever more precise depictions of social reality, but wanted to see, as do contemporary protagonists of a policy of nudging, for example, their insights turned into concrete policies. And while Quetelet was once eager to fend off the peril posed by the so-called, and I quote, dangerous classes, who is to say that today it's not dangerous individuals who might be targeted? Also termed hot dots in predictive policing. Targeted on the basis of what might very well turn out to be nothing but an illusion of knowledge. Let me come to my conclusion. What do we learn from our brief historical investigation? I think there are three aspects to heed when dealing with big data, social physics, and the societal hopes and interests associated with this new source of information about social reality. First, quite often, social physics is virtually devoid of any theory of that which it aims to describe. In its purest form, it is mere correlation that, by chance, happens on regularities it then reifies. More often than not, this takes the form of the regression to the mean, proving once more that the middle course is never wrong. In fact, social physics was premised on such a methodology, or lack thereof, from the beginning. Quetelet explicitly states that the main problem he was faced with in his day and age was the lack of comprehensive data, as I said before, implying that if one only had such comprehensive information, all the secrets of the world would automatically unfold. Pentland says as much when he sets out to collect what he calls the digital breadcrumbs of everyday behavior, only that today's computational capacities produce both plentiful data and provide the means to correlate anything with everything. And while Pentland aims to unravel, and I quote, a causal theory of social structure, he fails to explain the social and cultural reasons behind individual action and social interaction. Second, the manifest absence of any theory allows social physics to pretend to steer clear of any normative implications. Big data, or so it would seem, is only about facts. In doing so, social physics merely reconfirms everyday theories of a non-reflexive kind, and is thus just as normative as any account of social reality. This follows from the simple fact that any account of reality, and be it algorithmically derived, is necessarily pre-structured by its own vantage point. Pentland does not lose too many words on his goals and purposes either, as they seem self-understood. Social physics, he claims, helps us tune communication networks so that we can reliably make better decisions and become more productive. And the all-time classics, efficiency and innovation, also rank high in the unexplicated list of normative goals of such endeavors. Now, there is nothing wrong with productivity and efficiency, but it's a normative goal and nothing that is neutral. There is simply no place from which to observe social reality that would lie outside social reality. And even an algorithm is a human invention that runs on a man-made computer that is fed with data from worldly sources and later interpreted by scientists to refer to something and not the other. The danger here lies with this professional blindness to the predetermination of such allegedly value-free scientific knowledge, whose premises become invisible to those who only want to account for what is. What is ignored is the fact that what is and what should be are never natural categories. They are indeed political ones. Thirdly, and maybe most importantly, social physics threatens to reverse a decisive process of the social practicality and application of new knowledge. New knowledge, especially when derived from the sciences, is a, as we define it, capacity to act only if one controls the circumstances under which it might be put to use. Knowing about the workings of climate change, for example, maybe the role of greenhouse gases in warming the world's atmosphere, is of no avail in itself, as we can witness, when you cannot cut the emissions of such gases. To remind us of an important insight from science and technology studies, effects that were observed under the conditions prevalent in a laboratory cannot simply be repeated outside the specific settings of this laboratory. Social physics, to make a long argument short, will therefore propose to steadily change real-life settings in order to appropriate its immaculate mathematically derived findings. In other words, rather than presenting insights into social processes, the normative blindness of such a program of rendering the social world more efficient and productive is prone to create the social setting under which its implicit prescriptions hold true. This is a prime example of a self-fulfilling prophecy in Robert K. Merton's sense. An abstract depiction of reality becomes a factual reality by believing and thus creating the conditions under which such a reality may emerge. What we would therefore conclude is that the originator of social physics and the recent rediscovery of social physics based on big data are both preoccupied with a collection of data and the neglect of theory. theories and ideas that might account for the concentration, clustering, or distribution of attributes of social phenomena. What big data-based social physics lacks in theory, or so it would seem, is being made up by its implicit political agenda. Thank you very much.